Hi students, welcome back to this course, An Introduction to Mechanical Engineering. I am Professor Yao. Force in structure and machines. Forces in rectangular and polar forms, resultant of several forces. Moment of a force. The keywords for this section. Breakdown. The perpendicular lever arm method. The moment component method. Equilibrium. Unknown force. At the end of this chapter, you will be able to break a force down into rectangular and polar components. Determine the resultant of a system of forces by using the vector algebra and the polygon method. Calculate the moment of a force using the perpendicular lever arm and the moment component method. Understand the requirement for equilibrium and be able to calculate unknown forces in simple structure and machines. For the design standpoint, explain the circumstances in which one type of rolling element bearing would be selected for use over another and calculate the forces acting on them. Summary, the keywords. Force systems, moments, in the context of, perform a force analysis, visible, properties and terminology, building blocks, select component. The objective of this chapter has been to introduce the engineering concepts of force systems, moments, and equilibrium in the context of engineering structure and machines. Engineers often perform a force analysis to see whether a design will be feasible and safe. One of the skills that mechanical engineers develop is the ability to apply equations to physical problems in a clear and consistent manner. We also apply the concept of force systems to several different types of rolling element bearing that are used in machine design. Bearing has spatial properties and terminology, and mechanical engineers need to be fluent with those building blocks in order to select the component that is best suited for particular hardware. Forces in rectangular and polar forms. Forces in rectangular forms. The keywords. The influence of forces on a structure or machine. To describe a force, magnitude, and direction. Vector. Both direction and magnitude. Vector notation. Both phase. Horizontal and vertical components be broken down into. Before we can determine the influence of forces on a structure or machine, we first need to describe a force, magnitude, and direction. Forces are vector quantities, since their physical action involves both direction and magnitude. The magnitude of a force is measured by using the dimensions of pound in USCS and Newton in the SI system. Vector notation. Force vectors are denoted by using boldface notation, as in F. One of the common methods used to represent the influence of a force is in terms of its horizontal and vertical components. Once we set the direction for the x and y axis, force F can be broken down into its component along those directions. Keywords for rectangular components. Rectangular components. Projection. Horizontal. Vertical. Unit vectors. The magnitude of horizontal and vertical components. Vector algebra notation. Rectangular components. The projection of F in horizontal direction, the x-axis, is called Fx, and the vertical projection, y-axis, is called Fy. The pair of numbers Fx and Fy is just the coordinates of the force vector's tip. Unit vectors. The unit vectors I and j are used to indicate the direction in which Fx and Fy act. Vector I points along the positive x direction, and j is the vector oriented in the positive y direction. Just as Fx and Fy provide information about the magnitudes of the horizontal and the vertical components, the unit vector gives information about the directions of those components. The unit vectors are also named because they have a length of 1. By combining the rectangular components and the unit vectors, the force is represented in vector algebra notation. Forces in polar form. The keywords for polar components section. Polar components. Polar coordinates. How hard it pulls rightward and upward. Magnitude direction form. Polar to rectangular. Rectangular to polar. Principal value. Inverse tangent. Argument. Quadrant. Polar components. In alternative view based on polar coordinates, rather than thinking about a force in terms of how hard it pulls upward, rightward, and upward. You can tell someone how hard the force pulls and in which direction it does so. Magnitude direction form. Instead of specifying Fx and Fy, the polar components or magnitude direction form represents the force vector F in terms of two numbers, F and theta. Polar to rectangular. The force's magnitude and direction are related to its horizontal and the vertical components. Rectangular to polar. On the other hand, when we know Fx and Fy, the magnitude and direction of the force are calculated from equation. Principal value. The inverse tangent operation calculates the principal values of each argument and returns an angle between negative 90 degree and positive 90 degree, which will lie in either the first or fourth quadrants of the XY plane. Homework. Handwriting all keywords and submitting them to course Facebook. Just do the online quiz and see you next time.